My name is Amanda Zheng, and the title of my research is Aligned Orientation of Electrospun Nanofibers Promotes Neurite Outgrowth in PC12 Cells, and it was conducted at the Stevens Institute of Technology. Peripheral nerve damage affects over 20 million Americans due to several possible factors that are unavoidable, such as traumatic wounds, old age, and disease. There are drawbacks to the current treatments of nerve autografts or allografts, as nerve autografts takes a segment of nerve from the patient's own body to implement into the site of injury, which causes for increased recovery time and also another possible site of infection. Nerve allografts are when a segment of nerve is taken from a donor or a cadaver, in which there is a possible rejection from the patient. This study seeks to implement a solution of polycaprolactone, or PCL, electrospun nanofibers to be tested on PC12 neuron cells. They will be specifically testing aligned versus random nanofibers of the 8% PCL solution and thickness of the nanofiber in 8% versus 15% of PCL solution. My hypothesis was that the 15% thicker aligned orientation nanofibers would produce the most ideal and longest neurites, as they would have a long, straight, aligned track for the neurites to grow on, which is more similar to their conditions inside the human body, and also the thicker orientation would be closer to, again, the conditions inside the human body. Although there have been similar experiments in the past, my experiment is a novel approach, as aligned orientation has been tested in other types of material, such as polylactic coglycolic acid, or PLGA, and polyurethane, or PU, but it has not been tested yet in polycaprolactone, or PCL. And this is an ideal material for this application because it has a slow degradation time, which perfectly matches the slow regeneration of neuron cells. In addition, the diameter of nanofibers has been tested in the past, but only in a time span of 5 days, which is not ideal because you would want to know the long-term effects. So my study will study the effects for up to a 14-day period to see the further results. The 3 different conditions of cells were checked in on days 3, 7, and 14 via immunofluorescent microscopy to measure the length of the neurite or the ideal effectiveness of the neurite. It was discovered throughout days 3 and 7 that the 15% aligned drastically outperformed the 8% random and the 8% aligned solutions. However, by day 14, the growth of the 15% aligned solution had slowed down, and we predicted that this was because of an excess of cells seated onto the 15% aligned scaffold. Without this excess of cells, we predict that the growth of the cells on the 15 aligned scaffold would have drastically continued. However, this is something that we would want to consider to study in a future experiment. In conclusion, the ideal conditions for nanofibers are the aligned orientation and thicker diameter fibers of the 15% PCL solution, which ended up being around 1,800 nanometers. These results are a promising candidate for future nerve tissue engineering and possible applications in clinical trials, as there is a large amount of peripheral nerve damage injuries and there is a large need for treatments. This is an ideal solution because, first of all, this solution of PCL is biocompatible and FDA approved, meaning that it will be implemented into the body with ease. Secondly, PCL is inexpensive and will make the treatment very cost effective. And lastly, the slow degradation time of PCL is ideal to match the slow nerve regeneration time. Thank you.